Two cars are moving in different directions from a 90-degree intersection. One car moves 250 miles north in 5 hours. The other car is moving west from 2 p.m. to 5 p.m. What is the rate of change of the distance between the two cars?
The problem gives us the time to move a certain distance for one car and gives us the miles per hour and time for the other car. It asks us to find the distance between the two cars at the endpoints. So we know this will be a simple right triangle solving for the rate of change in the distance between the two cars. Let's call the car moving west x and the car moving north y, with the distance between them s. For car x, we know that the rate dx over dt is equal to negative 40 miles per hour because it's moving west on the coordinate plane. For car y, it travels 250 miles in 5 hours. Because this is a right triangle problem, the best formula is the Pythagorean theorem, x squared plus y squared equals s squared. When we take the derivative of it, 2x dx dt plus 2y dy dt equals 2s ds dt. With the 2's crossed out, we're left with missing variables such as x, dy dt, s, and what we're trying to solve for ds dt. We can find these variables by using the equation d equals rt. X is equal to dx over dt times time. Substituting the variables, x equals negative 40 miles per hour times 3 hours from the car time, with x equals negative 120 miles. We can do the same for y. Y equals dy over dt times time. 250 equals dy dt times 5. dy dt equals 50 miles per hour. To solve for s, we can use the Pythagorean theorem with the variables we now have. Negative 120 squared plus 250 squared equals s squared. S will equal 10 times the square root of 769. Now we can isolate ds dt and substitute in the variables. After simplifying, we get 1,730 over square root of 769, which is equal to 62.4 miles per hour as the rate of change of the distance between the two cars.